Hi y'all. Okay, it looks like we are going. Awesome. Okay, so today I'm going to be talking about hypothesis testing mostly, and depending on the time, I will also be talking about the different types of errors and dig a little bit deeper into that time depending again. Okay, so hypothesis testing. So for anyone who can't remember 8th grade science or whatever, hypothesis is a specific testable statement of a relationship between two variables based on theory or prior research. So that's more of a definition for statistics and for what we're talking about, so that's a bit more helpful. And relationship can be correlation, causation, or really any type of relationship at all between these two variables. And the keyword here is bolded, it's testable. It needs to be testable. Okay, and we need to use inferential statistics to test our hypothesis. So, as a reminder of what they are, inferential statistics are when you infer that a sample is accurate to a population, and it looks at two or more variables at the same time, and it allows us to make inferences about relationships between variables. Okay, so our null hypothesis states that there is no relationship between the two variables. And our null will always be the same for whatever we are doing, but our alternative hypothesis is what we control, and that will change based on the different research that we are doing, and it is what we expect our relationship to look like. So we can have two kinds of alternative hypotheses here. We can have our directional hypothesis or our one-way/one-tailed. So this is when we have one set direction. When we're proposing it's going to increase, that they will both increase together, they will both decrease together, or whatever else we're thinking. So an example of this, I use a lot of Grey's Anatomy in this one. I don't know why, but anyway. Okay, so example is watching Grey's Anatomy will make you want to become a surgeon more than not watching it. And then we also have our non-directional hypothesis, or our two-way or two-tailed. So this is a very broad, basically it's saying it's not going to be the null. So it's our alternative hypothesis that's saying that there is going to be a relationship, but like I don't think that there's going to be necessarily one or the other. It's not going to go up or down. It's just, there's just going to be a relationship. So an example of this is saying that there will be differences between Grey's Anatomy watchers and people who don't watch it. Okay, so our main question with hypothesis testing, when we get to the end, we say, okay, are we rejecting the null or failing to reject the null? And you don't say we accept the null, you always have to say like reject or fail to reject. Okay, so again, Grey's Anatomy. So I totally made up the sample. Like there's absolutely no, I don't know. This could be realistic, could not be. I literally just put in random numbers. Okay, so let's say our null for my example is Grey's Anatomy has no effect on desire to go into the medical field. And what I think our alternative is that Grey's Anatomy has an effect on people's desire to go into the medical field. So then if we look at what type of hypothesis or alternative hypothesis I just have a non-directional. I'm not saying it's going to increase or it'll decrease. I'm just saying it's going to have some kind of an effect or relationship. So the data that I totally made up, again, I just kind of like went off of, this sounds maybe roughly accurate. So let's say that in this study we interviewed like sophomores in college. And so we have our people over here and how many episodes we watch weekly. And 24 people said that they don't watch any weekly. 26 said like, oh, 1 to 2. 21, 3 to 4. 17, 5 to 7. And 12 people said that they watch 8 or more. So like at least an episode a day about. And then people who have a desire to go into the medical field. So I did like a 1 to 5 scale here just because it made it easiest. So 5 is like, oh yeah, absolutely, I want to go into the med field. 1 is like, no, I definitely don't. 3 could be like undecided or just unsure or whatever else. Okay, so 22 people said absolutely not. 17 people said 2. 33 people were unsure, they said 3. again, I totally made this up, so it's like, yeah, sophomore in college, maybe like a third of us out of, I did a sample of like 100. Like, yeah, that sounds accurate. Anyway, then 17 people said 4, and 11 people said 5, absolutely, I want to go into the medical field. Okay, and then I definitely did a stats class like a year and a half ago, and we learned how to plot all this, but I don't remember anything from that, to be honest. And I still have my notes, but I didn't want to dig them out. So I just made a visual for myself that makes sense to me and probably makes sense to no one else. But here we go. Okay, so I made this like kind of little bar thing, and I said, okay, like this thing, oh, my things got cut off. I actually did labels and they got cut off. Oh well. Okay, so I said down here is like episodes and desire to, or episodes of, oh my gosh, I can't talk. Episodes weekly of Grey's Anatomy / desire to go into the medical field. And then my y-axis is number of people. I counted up by 5s on here. It's like 5, 10, 15, 20, up to 35. Because my highest number was 33. And so my blue dots are episodes per week, and my red is desire to go into the medical field. And so I have the numbers right here in my lap. So we have episodes per week is 0, and 24 people is the blue. And then for red, we had a 1 degree desire to go into the medical field with 22 people. Anyway, and so on and so forth. I don't want to keep repeating all that jazz. So it looks like there's roughly a relationship, like especially between the 1st, the 4th, and the 5th points. The 4th especially were both exactly 17. So again, in real life, you're going to have, like a ton of different calculations and stuff that says like, okay, here's how accurate your stuff was. Here was like the p-value, the probability of this happening. Anyway, I'll get more into that later. But just based off of this, I just kind of said, just to make it easier, like, okay, it looks like there's a pretty good pattern here, so we're going to go with our alternative null, which means that we reject the null. So then I remember, so then I put my little side note here, remember things would be much different, and yeah, I think that looks legit. And we have to look at other things like p-value, which is coming right up. Okay, so our roll-up chance, real fast, is our biggest concern with quantitative data analysis. I don't know what got cut off right there, or what I forgot to keep typing. I don't know. Okay, so we want our, I think it's supposed to be like, is it up to chance, or something like that. We want our chance factor to be as small as possible, which, I mean, you guys know what chance is. It's just like, you throw something into the wind, and it just so happens to be like that. Okay, so our p-value, moving on, is percentage of being wrong. So if we had a p-value that is less than 0.07, it means that we have a 7% chance of being wrong. And so our programs are going to give us our p-value. So the program that we use in this class is Excel. Excel is a pal. And if the p-value, which is also known as our significance level or significance value, is less than 0.05 or 5%, we can reject the null. So that's basically saying that there is a relationship between our two variables, because the chance of getting those results otherwise are really slim. Okay, so now moving into errors. So I'm just going to do a more brief than I expected thing on errors because of time. Okay, so type 1 error is a false positive. And something that was really great that in the lecture she mentioned was thinking of a pregnancy test for both of the errors. And it's like a false positive, is when you, is when the test comes back saying like, oh, you're pregnant, but you're not actually pregnant. So it's when you accidentally reject the hypothesis when it is actually true. So you're finding a difference that isn't actually there. So there's only 5% chance of finding a type 1 error with p-value of 0.05 and 7% chance of finding it with p-value of 0.07 and so on and so forth. Okay, so an example that I came up with, again, I don't know why I'm doing like a ton of medical things today, but here we are. Okay, so let's say that there's a CVD, which is it's heart disease. I can't talk. There's a heart disease patient who starts a new set of blood thinner meds. At the same time, he or she underwent a lot of stress in their life, so we conclude that their blood pressure went up because of the blood thinner. Now, in reality, when you have stress, your blood pressure goes up. So then, this is type 1 error because we found a result that didn't really exist, because blood thinners should not be making your blood pressure go up. And, okay, so this isn't to be confused with, like, the whole correlation is not equal to causation, because, you know, it can be that, but it isn't, so don't get that in your head. Okay, and this type of error is a lot worse than type 2, which is our false negative. Okay, so this means that we failed to reject the hypothesis null when it's actually false. Okay, so this is like saying, oh, there is a baby, but the pregnancy test came back negative. So not that big of a deal, because obviously in that case, the woman is eventually going to figure, oh wait, I actually am pregnant. Okay, so this is not finding a difference that is actually there. And this isn't as bad, like I said before. And if we, there's a great example that our professor gave in the lecture, and one that I thought of was kind of going off with a heart disease patient again. So let's say cardiovascular disease. Cardiovascular disease. That's what it is. Okay, so let's say that the doctor takes the person off of the meds that could help them in the long run. This is not good news. So that would be type 1, which, you know, obviously bad. And then same example in type 2 would be if the patient didn't undergo any other stress in their life as they're going on to these new medications. So the doctor doesn't see this difference, but like he or she just keeps the patient on the blood thinner a bit longer or whatever to see what else happens. And so this doesn't hurt people, so it's definitely a lot better. So if you're going to have an error, go for error 2.